Okay, everybody, so obviously we're starting this video with a question. Alright, here it is. Can a curve have a slope? Alright, and I need to pose the question, and two, I need kind of a dramatic build up to it uh, so that you see the force of the question. So let's start by thinking about it like this. A line can have a slope, alright? Very simple. You find the slope of a line by identifying 2 points on the line, measuring the rise, measuring the run, dividing those two numbers. That's what this formula that we have used in the previous video, y2 minus y1 over x2 minus x1, that's what that does. It measures the rise and the run. It's just a measurement. I could get my ruler and measure the rise and measure the run, and it's all the same thing. Whether you have a line with points on it and you do it this way, whether you have a line and you go about measuring the rise and the run, it all means the same thing, okay? And it doesn't matter which 2 points you choose. If I happen to have chosen this point right here and this point over here, and I measured the rise and I measured the run, then I would get the same number for the slope. Even though that rise is bigger than this one and this run is bigger than that one, when you divide them, you'll get the same number. All right. So yes, a line can have a slope, but the question was, can a curve have a slope? Well, a curve is, by definition, it's not straight. Okay. This is what I'm thinking about. Can a curve like this have a slope? It really doesn't make sense to plot 2 points and find the rise and the run. When it looks like this, it's not straight. It just doesn't make sense to do that. But a curve can have a slope if we imagine it like this. So here on the screen, you can see the original curve, and then you can see this curve like where I'm trying to imagine it one little piece at a time. And if you can imagine all these lines blurring together, then you'd get that curve. But we could say that a curve is curved unless you look at it on an incredibly small scale. So like every little piece of it looks straight. Okay, it's kind of like if you can imagine the Earth as a globe, as a perfectly round sphere. If we were standing on a sphere the size of the Earth, from our point of view, on the ground, it might not look like it was round, okay? Or it probably wouldn't look like it was round. We're just looking at it too close. We'd have to step back and see more of it. Anyway, so yes, a curve can have a slope if you look at it one little piece at a time. If you look at it in terms of these microscopic segments. And I might say like, well, this piece, that part of the curve, that line right there, that's pretty steep. That's nearly vertical. And it's different everywhere else. If you look right here, well, it's almost flat. See that little line right there? It's almost horizontal. So that's the way that we need to conceive of what the slope of a curve is. Okay? Just look at like a really small part of it. And you got the idea. So there's the whole curve, right? It's not straight. But that little piece right there, it looks straight, right? You get the idea. Okay. So next topic is this thing called the tangent line to the curve. So it's time for some vocabulary. Imagine that you've got the curve. It's drawn there in pencil. And with my red pen, I drew the tangent line to the curve at this point, point A. Okay? The tangent line to a curve intersects it at one and only one point. Just like you see there, okay? And the slope of the curve at this point is the same thing as the slope at the tangent of the tangent line at the point. And all I'm trying to say there is, obviously the tangent line is a line, and every line has a slope. But the slope of that tangent line is the same as the slope of the curve. Imagining it like this. Okay, so if you want some help seeing that, then we can say like Well, obviously, in the big picture, the tangent line there in red is not the same thing as the curve. But if you zoom in on that point, you can't even tell there's two things there, really. They blend together. Like if you have a close enough perspective on that point right there, the tangent line and the curve look the same. That's why we say that the slope of the curve at any point is the same thing as the slope of the tangent line at that point. All right. So now that's vocabulary. There's obviously no math on paper at this point, but now you know what the tangent line to a curve is. Now you should know what we mean when we say what the slope of a curve is. You have to look at it point for point. The slope here at this point is different than it is at that one, and so on. And now you know what the tangent line to a curve is. All right? Okay. So on to the next topic then. We'll build this up a little bit more. Next question. How do we measure the slope of a curve? Well, we use this thing called the derivative. All right? So just looking at this, we'll say, all right, y equals f of x. That's a function. A curve, a graph, a function. There's lots of names for this. In this lesson, just by the nature of the topics, I normally call it a curve. Well, you can call it whatever you want. All right? This thing, now this is just mathematical notation. It's just a symbol, but the way we read it is y prime or f prime. That's called the derivative. This is the thing that measures the slope of the curve for us. All right? At this point, I'm going to have to ask you, don't worry about how you find y prime. We'll worry about that later. For now, I just want you to get used to how you use it. All right? But it measures the slope of the curve. You know what it does. I need to get you to see how you use it. All right? How you find it, don't worry about that, okay? All right, now, one more thing about the notation. This y prime, which is what we call that, or f prime, that's an apostrophe right there. But that's the symbol we use for this thing called the derivative. All right, so you get in the terminology. Y or f of x is the curve, the function, whatever. Y prime or f prime is the derivative, okay? So let's do something basic to start with. So say you have this curve, f of x is equal to root x. And I tell you that the derivative is f prime is 1 over 2 root x. So that formula right there, that's the thing that we use to measure the slope of this curve at whatever point you want, all right? And then the question is, calculate the slope of the curve at the point 4, 2. Well, I happen to have drawn it here, just in case pictures help you feel better, or if you feel like you understand it better when you see a picture. There's the picture. So what is the slope at that point right there? If I could like zoom in so close to this thing, I'm looking like right there, and I see that little straight segment right there. You see that? How steep is that? Well, that's what f prime tells us, okay? So we could say something like this. The slope at the point 4, 2, which you're looking at right there, is equal to f prime, and what's the input for the derivative? See how it says f prime of x? What are you supposed to plug into that? Well, x. You take the x coordinate of the point that you want to know the slope at. So we want f prime at 4. Given that this is f prime, 1 over 2 root x, that's going to be 1 over 2 root 4. Okay? We do our calculations. Root 4 is 2. 2 times 2 is 4. It's 1 over 4. Okay. So the slope of the curve at that point is 1 over 4. It's like this little piece right there is like a line where you run for a rise of 1. That's how steep it is. I thought I would try to demonstrate that. So how about just to see that we can tell that the slope at this point is 1 over 4, I thought I would draw a line with the slope 1 over 4, and we can see them together. All right. So how would you draw a line that has a slope of 1 over 4? Well, that's the rise and that's the run. So here I drew another graph. I tried as much as I could to make the scale the same. It would have to be the same to make this comparison. But I'll put just an arbitrary point like that. And I'll go over 4 and up 1, like that. And if I connect these, then that's a line with a slope of 1 over 4. That line has a slope of 1 over 4. All right. And all I'm saying is that these should look the same. All right. Here is the curve, and it has a slope of 1 over 4 right there. And there's a line with a slope of 1 over 4. They should look like they're slanted or sloped in about the same way. You know, if my graphs are to scale and my measurements are accurate, then this will look like that. That's what we're saying. That's all we're saying. If you could zoom in to that point on this graph, this is what you'd see. You'd see a line like that. You'd see a line with a slope 1 over 4. Now, I talked a lot about that, and I try to get you to understand it, but I hope you see that, well, it doesn't look like the math is that hard. You just take the point you're interested in and take the x-coordinate for the point and plug it into the derivative, and you'll get the slope at that point. Slope right there is 1 over 4. All right. So let's try something different, okay? So in my the video that comes before this one, I introduced the notion of the secant line. And I need to get you to see the connection between the two of these. All right? So here it goes. So this one says calculate the slope of the curve. Y is equal to x squared at the point where x is 4. And I tell you y prime is 2x. That should be easy, right? You take the x coordinate for the point, put it in there, you'll get the slope at that point. Okay? So now that's so easy that that's not really the part I'm worried about. I wanted to show you this in a way that I can connect it with that question down there. Okay? So let's do like this. Imagine you've got this parabola, all right, and there's this point 4 for x. What would the y coordinate be? 16, right? And this is y is equal to x squared. Then right there, the slope at that point, we take the derivative and we put the x coordinate into the derivative. So that would be 2 times 4, which is 8. Okay, 2 times 4. X coordinate's 4. The derivative is 2x. All right, so that's pretty steep. Imagine a line where you went over 1 and up 8. That'd be pretty steep. But the slope here is 8. All right, that's not hard. But about this one, I think when we do this, that's about what we're going to get for the answer. That's my prediction. I want you to see why that prediction is true. Why would it be that if I found the slope of the secant line to that curve between the point where x is 3.9 and the point where x is 4.01, why would that be about 8? Well, because I'm saying that little piece right there at that point has a slope of 8. So, doesn't it seem natural then if I took this point right here? Where's that point? You know, that's just a little bit to the left of 4 if it's 3.9. So like that point has x to be 3.9. And then this point, 4.01, that's just barely to the right of this one. So like right there, x is equal to 4.01. And if I found the secant line between those, it would just it would all blur together. You know, if the slope of the curve at that exact point is 8, then the slope of the secant line between these points that are right next to that one should about be 8. All right. So hopefully I've convinced you of that. I think the picture says it, but let's do the math and see that we're right. Well, we're going to get about 8. So how do we find the slope of the secant line? Well, it's a line, and you find the slope of a line by rise over run. But let me write like this. So slope of SL, slope of secant line, that line that's in red right there. Do you see that? Between the points where x is 3.9 and 4.01. We need to do y2 minus y1 over x2 minus x1. How do you find the y coordinates on the curve? If that point has an x coordinate of 3.9, what's the y coordinate? 3.9 squared. If this point has an x coordinate of 4.01, what's the y coordinate? 4.01 squared. So can't we do this? 4.01 squared minus 3.9 squared. There's the rise. And then the run would be 4.01 minus 3.9. And that'll be about 8. That's my prediction. But I'll do my calculations off screen. So 4.01 squared minus 3.9 squared. Divide by 4.01 minus 3.9. Okay, and this is what I get. I get 7.91. I said it would be about 8. It's not that the math is that hard, but what I really need to convince you of is that we're not surprised at all that we got a number real close to 8. So yes, the slope of a curve is related to the slope of the secant line to the curve. If the points are really close together, if these points are really close to that initial one, all right? That's how we do it. All right. So next topic then. So check this one out. So give the equation of the tangent line to the curve, f of x is equal to root x, at the point where x is 1/4. Okay? All right, now I told you before, earlier in the video, what the tangent line was. Okay, so you got the concept, hopefully. Quick reminder about the curve and the tangent line. There they are together. They meet at some given point. So I'm talking about the curve root x and the point 1/4. All right. So usually I think it does help to have a model. I understand if you don't want to draw a picture every time you do a problem, but I'm the one trying to explain it, so I will do that. I will show you a picture. So f of x is root x. Looks like that. So there's our curve. All right. And I got this point where x is 1/4. So it's, this is not to scale. It doesn't have to be just to show you this, but 1/4. All right. 1/4 for x. There's also a y coordinate for that point, right? On this curve, every x is paired with a y. What is the y coordinate for the point where x is 1/4? Square root of 1/4 is 1/2. All right, so that's that point. There's the x and the y. And the tangent line that we're looking for would be this right here. Okay, there's the tangent line to this curve at that point. And I'm looking for the equation. Okay, what's the equation of that tangent line? Well, the tangent line is a line. And lines have an equation, y equals mx plus b. All right? So that's going to be our answer. It would just be a matter of finding m, which is the slope of this line, and b, which is the y-intercept. If you knew each of those things, you'd have your answer. That would be the equation. But let's break it into two parts. First, let's find the slope, or m. How would you find the slope of the tangent line? Didn't we say that the slope of the tangent line was the same thing as the slope of the curve? Yeah, they're the same. However steep the curve is at this point is how steep that tangent line is. So we can use the derivative. Now, in another problem earlier in this video, I gave you the derivative. I told you that it was 1 over 2 root x. Okay. For right now, we're not going to worry where this comes from. I'll give it to you for now. So yes, that's the thing that will tell me the slope of the curve at that point. And as a consequence, look at my picture. It will tell you the slope of this tangent line. You can't tell them apart. Whatever the slope of the curve is right there, that's the slope of the tangent line. Now I want to know what the slope of the curve is at this point where x is 1/4. So I want to do f prime of 1/4, which is 1 over 2 root 1/4. And the square root of 1/4 is a half. 2 times a half, that's 1. 1 over 1 is 1. So the slope of that line is 1. Okay? So I have a partial answer. Okay? This is not a full answer to the question, but a partial answer would be that the equation of this line right here is y is equal to x plus b. All right? So why is that? Well, because the slope is 1, and that's what m is. Now, I can find the y-intercept by noting that that point is on this line that I'm trying to find the equation of. So if I take that x and put it here, and that y and put it here, that would be valid because that point is on the tangent line. And if I put those numbers in, I can find b. So okay, on this line right here is the point 1/4 for x, 1/2 for y. So I will put 1/2 for y, 1/4 for x, and then that will be enough information to find that last number right there. Okay. If I try to solve for b, I'll move that 1/4 over, and I'll get b is equal to negative 1/4. I'll get 1/4. So I'll get 1/2 minus 1/4. Okay, so 2/4 minus 1/4 is 1/4. So b is equal to positive 1/4. All right. Now, so from that, I have my answer. The equation of the tangent line is y equals x plus 1/4. It has a slope of 1. It hits the y-axis at 1 over 4. So now let me write my answer separate from the work. And put a box around it. I want that to stand out. There it is. That's the equation of this line right there. Okay, so let's try another one. And this time I'll go through the procedure. I won't draw a picture. You know, once you've seen the picture, you can imagine the same kind of thing happening with other problems. But okay, so here it is. It says give the equation of the tangent line to this curve at that point. Okay. Now, I need to give you a hint. I need to tell you what the derivative is. It's 2x, all right? F prime is 2x. Remember, we're not going to worry about where you find that yet. We'll worry about that later. So there's the derivative. Now, there were those 2 steps, right? First step, what is the slope of the tangent line? Slope of TL, slope of tangent line. Well, you use the derivative to figure that out. So we will do f prime of, and I want the slope of the tangent line at this point where x is 1/2. So I'll do f prime at 1/2. That's going to be 2 times 1/2. That's going to be 1. So the slope of the tangent line is 1. And then as a partial answer, since I know the form the answer takes is this, y equals mx plus b is the slope of a line. The tangent line's a line, so it looks like that. Well, then I know that as a partial answer, it's y is equal to x plus b. All right, the slope is 1. How did we find b again? Well, the tangent line meets the curve at that point. They have that point in common. So this point, it's on the curve, but it's also on the tangent line. So I can say in that equation of the tangent line, this x gives you that y. I can put those x's and y's in and find b. So it says for that point, y is 5 over 4. And then x is a half. And then as soon as I put that in, then b's the only thing left. And so I can find that. All right. All right. So I'll do a little math here. We'll have to subtract the 1/2. We'll get 5 over 4 minus 2 over 4. Okay. 5 over 4 minus 2 over 4. That's going to be 3 over 4. B is 3/4. Okay. All right. So from that, I have my answer. Y is equal to x. That's what we found the slope to be. And I found b to be 3/4. X plus 3/4.